Hello students, welcome to Unit 4 Notes, Section 5.1. This one is on mid-segments, but for this warm-up, I'm going to do this warm-up with you. It says find the midpoint of each side of each triangle. So here's your midpoint. Then connect each midpoint to the midpoint of every other side. For an example is provided for you. So here we went from Z to Y. Now this goes up 3 over 1, so what's half of that? Well, up 1.5 over a half, so that's where we found our midpoint. This one, XY, goes up 3 over 2, so I went up 1.5 over 1, that's the midpoint there. And this one just 3 long, so I went 1.5 there. So I'm going to do this now for my next one. I'm going to find the middle here. That looks like the middle, because it's up 2 over 1, so I'm going to go up 1 over a half. Same thing on the way down over here, and then right in the middle here. So here's my connected locations. And those are midpoint to midpoint of all 3 sides. And this next one, I'm going to go, this one's 1, 2, 3, 4, 1, 2, 3. So I'm going to go up 2 over 1.5. That's that. And then we go 1, 2, 3, 4, 5, 2. So I'm going to go 2.5 up 1. That's the middle of that one. And then this one is over 2 over 2. So it's over 1 over 1. And now I have, let's change the style to green. Why not? We'll change it to green. For this one, we now connect these. Okay, so we went mid-segment to mid-segment. Awesome. So the mid-segments, the triangle mid-segment theorem, which is what we're going to do, mid-segments of triangles. Mid-segment, we're not going to do coordinate proof. We're going to use properties of the mid-segments to solve problems. So if a segment joins the midpoints of 2 sides of a triangle, then the segment is parallel to the third side and is half its length. Here's what's so cool. Check this out. For this one, let me find it, color red. No, maybe I don't want to do red. Maybe I want to do any other color. Let's do blue or purple. What this is saying is that this side right here, this mid-segment, is actually parallel to its base. And that this one right here, this mid-segment, is parallel to this base. And this last one is actually parallel to this base. So, or maybe I should flip those around. It doesn't really matter as long as they're going the same direction. Not only is that true, but this part here is half of this part here, or this part is equivalent to this part and this part. So really, not only are they parallel, but here's something else we know. We know that this is congruent to this is congruent to this. This is congruent to this is congruent to this, and this is congruent to this. So not only do we know that this part is half of this whole thing, ij, but this is actually equivalent to just I whatever, and then whatever j. So not only are they congruent, but they are parallel. So together, when they're congruent and parallel, there's a whole lot of markings that I would use. I would use this, and this, and this, and this, and this, and this, this, and this, as well as this and this. Whew. All right, this one. And this one. And then lastly, running out of, okay, 1, 2, 3, 1, 2, 3. So we got a lot going on with these. They're pretty much perfect. They're really nice. So here's my suggestion. If I were to give you a number here, you're going to double it and you'll know this whole length. or if I give you a number here, you're going to find half of it, and you're going to get this length. Let's say variables are in both places at once. Don't make it more complicated. Sometimes finding a half of something is more difficult than doubling something. So why don't you just double this one and set it equal to this one, assuming that you have variables. So the inner one is what you're going to want to double and set equal to your base, or your outer one. Okay, so let's take a look. Let's actually do some of these problems involving the triangle midsegment theorem. So here it says, in triangle EFG, H, J, and K are midpoints. Boom. Awesome. Find HJ, JK, and FG. So I'm going to do HJ. I'm going to have to find JK. I'm going to have to find FG. So HJ, let's see. HJ is this one right here, which is going to be half of this one right here. So this EK is 50, KG is 50, HJ is also 50. And again, reason why is we're dealing with midpoints, so HJ is 50. Take a look at this one. We have JK. JK is going to be half of this right here. So if that's 60, this is 30. So I'll do 30, 30, 30. Here's something cool as well. 50, 50, 50. And then that one is 40, which would make this one 40, which makes this one 40, which makes this whole thing 80. So let's see. FG is what it was asking for, which is 80. It wanted the total length. JK is 30. And HJ was 50. And again, that's it. So you have your parallel, you have your congruence, all good. All right, AB, ooh, don't forget these sides are congruent, right? So this piece and this piece are congruent. So here they listed AB and BC as being congruent. So AB is 10. So if AB is 10, so is BC, which makes this whole length, which makes this whole thing 20. Then they give me CD is 18. So CD is 18, making this one 9, because that's your mid-segment. How do I know it's a mid-segment? Well, it's connecting the midpoints. And how do I know they're midpoints? Well, because AE has a tick mark, and so does DE. And AB has a tick mark, and so does BC. So I know that this one right here has to be, that these pieces are congruent, making this a midpoint, making this half of the length of DC. All right, so it wants us to find EB. Well, EB is 9, so that was easy. So EB is 9. BC is 10. And AC is the whole thing, which is going to be, AC is going to be equal to 20. So I'll just change the color of this one. Whoops, I didn't mean that. All right. Notice they didn't give us EA, but we could find DE if they did, and then we could double it to find DA if we needed to. All right, identify the parallel segments. So if those are midpoints, name the pairs of parallel segments. So I'm going to say, let's see, AB is parallel to DF. AB is parallel to DF. I mean, it's also parallel to DC and CF, but I'm going to use the whole segment when I name it. And I'm going to say BC is parallel to ED. Uh-oh, hold on. BC is parallel to ED. This is a parallel symbol. Really should be a little bit longer. That means parallel. So AB is parallel to DF. BC is parallel to ED. And lastly, whoops, we're going to have AC is parallel to AC is parallel, well, CA. Let's call it CA. CA is parallel to FE. Now, can you say that CA is parallel to FB? That is true. So there's multiple things that you could say for this as well. I mean, maybe I should just list them all out. So it's parallel to really any of these. Oops. So I'll leave FE, but I'll do a couple more. So FB and BE are true as well. Those are true statements. So this one I guess I'll do as well. So ED is EA and AD. And then this last one, let's see, DF. DF is DC and CF. DC and CF. Here's what I'm going to do. I am going to circle these and put that these are the preferred answers. Let's see. Preferred. I just want to make sure. That looks wrong. No, it is. Okay. Preferred answers. But there's, yeah, see, that R is too small to see. RED. Let's see. Preferred answers. So those are preferred answers, but again, they're not the only ones. Okay. Find the measure of angle VUZ. Well, let's see. If this is 65, this is 65 as well, just because these are parallel. Right, so parallel. So 65 degrees. Those are corresponding angles. So the measure of angle VUZ is 65 degrees. That was quite easy. All right, let me try to, maybe I should try to make this look a little nicer up here. Okay, move all this down just a little bit. There we go. All right, that looks nice, nicer. Okay, there we go. So those are all good. So now here's another question. Kate wants to paddle her canoe across the lake. To determine how far she must paddle, she paced out a triangle counting the number of strides as shown. So these represent strides, not feet, not meters, just strides. So 150, 150, 80, 80, 250 strides. Obviously, she can't stride across here, but what we do know is that if, let's see, we use purple. Okay, so orange is next. If this is congruent to this and this is congruent to this, what we know is we have midpoints, making this length half of the longer length. So this right here is going to be 125 strides. So in theory, if she could walk on water, it would be about 125 strides. So if Kate's stride average 3.5 feet, what is the length of the longest side of the triangle? So the longest side of the triangle, which is 250 paces, is going to be 250 times 3.5 feet per pace, which is going to give us 750, 825. Let me see. So 3.5 times 250 is 875 feet. Okay? And now the next one is, what is the distance that she must paddle across the lake? So for this one, we're going to do 125 times 3.5, which is half of 875, which is going to be 437.5 feet. And that's the answer to that one. Great. The next one, CD, is a new bridge being built over a lake as shown. And so the question is, what's the length of the lake? How long is the bridge in miles? All right. Well, it looks like the lake is, I'm sorry, here's your bridge. It's going to be half of this number. So it's going to be 1,320 feet. So 2640, so I'm going to do 2640 divided by 2 is 1320 feet. Okay, 1320. And then it says, how long is a bridge in miles? And for miles, you're going to have to take your 1,320 feet and divide it by 5,280 feet to get your how many miles there are. So there is 1 mile and 5,280 feet. So 1,320 divided by 5,280 is 0.25 miles. So the answer is 0.25 miles. So the bridge is 0.25 miles long. All right. And that's it. We'll be doing, I think I can do this. Wait, how many? 1, 2, 3. 1, 2, okay, 16 problems. I'm going to have to continue on a little bit. So continue to watch this video. So for this one, here's we have mid segments because we have a midpoint here and a midpoint here. This is half of 18. So what I can do, my suggestion is, I know this might take a little bit longer, but is to always double this number and set it equal to this number. So 2x equals 18. So if I always double the inner and set equal to the outer, I'll always get what I want. We get x is 9. So yes, could I have found half of 18? Yes. Sometimes though, with variables, it's not as nice and easy to find half of something. Okay, so here I'm going to do 2 times 5x equals 70. So 10x equals 70. So x equals 7. Which 7 times 5 is 35, so that makes sense. It is half of the 70 I was looking for. So now I'm going to do 3x, but I'm going to do 2 of these is equal to 84. So I'm always doubling that inner one. So 6x equals 84 divided by 6. So x equals, let's see, 6 times 12 is 72. 6 times 14 is 60, and 24, which is 84. So we have 14. And 14 times 3 is what? 15, 30, 45 minus 3, so 42. Yep, 42 would be half of 84. Awesome. The next one, 2 of these, make sure you use the distributive property. You have x minus 1. So 2x minus 1 equals 45. So 2x minus 2 equals 45. Add 2. You get 2x equals 47. And so now 2x equals 47. You're going to have to divide both sides by 2. So x equals 23.5. See how this one ended in a decimal, so it wouldn't have been that nice. 23.5 take away 1 is 22.5. 22.5 is half of 45. But again, finding half of 45, and then you would have to add 1 to it, and it just gets more complicated. So that's why I say always double the inside, then set it equal to the outside. So here, 2 x minus 1. Oh, sorry, 2 times 5. See, that's the inside. I almost messed up. Equals x minus 1. It equals 1 outside. So 10 equals x minus 1. So add 1. We get 11 equals x. So that makes sense. 11 minus 1 is 10. And that is exactly what I needed to get. Okay? Next one. 4 times 2 equals 5x minus 2. So 8 equals 5x minus 2. So 10 equals 5x. So 5, oh, sorry, I'm dividing by the wrong thing. Divide both sides by 5. I'm doing the math way too quick in my head. So 2 equals x. Okay, so if 2 is x, that's 10 minus 2, which is 8. And 8 is double 4, so we are good to go. All right, next one. Points E, D, and H are midpoints of TUV. Perfect. UV is 80. So if UV is 80, that makes this one 40. This is what I like to do. To be honest with you, I like to just kind of draw them all in as I get my information because they're so easy sometimes. Like this one, if UV is 80, UV is the whole thing is 80. That makes that 40. That makes that 40. That makes this one 40. Boom, and I'm done with that. The next one is TV is 100. So TV is this side right here, which is 100, which makes this 50, which makes this 50, which makes this 50. And the last one is HD is 80. So HD is this one right here. So that's 80. So that makes that 80, which makes that 80, which makes this whole thing 160. And I quickly now can find all of these items. So HE is 40. Oop, this is poor practice. That should have a line above it. This one has a line above it when you talk calling it by name, which is what I did. Then the line above it drops away when you're actually answering the question, right, with an equal sign. So HE equals 40. ED is 50. So ED is 50. Again, I'm going to want a little mark above ED. Find TU. TU is 100. Whoops, no line above it. TU. Wait, TV was 100. Oh, TU is 160. I knew that was weird. Okay, 160. My bad. Yep, TU is 160. Yep. Okay, and TE is also in red, so TE is 80. Whoops. All right. Okay, identify pairs of parallel segments. So I'm just going to list the smaller ones and the longer ones, like the shorter and longer. I'm not going to list all 9 possibilities. So I'm going to say UY is parallel to, is parallel to VX. Oh, you know what? I'll call it XV. I'll go in the same order. XV. So UY, wait, oh, that was the same order. UY and XV. And then we will do, oh, you know what? I know what I was doing. No, let me go back. I'll do YU. I'm going to go in the direction of the arrows as well. YU and XV. Okay, the next one is going to be UW is parallel to TX. I'll go in the same order. So TX is over here. And then the last one, it's weird because they're all backwards of what I was doing. So the last one is this one, which is this one. So WY is parallel to WY is parallel to WY is parallel to VT. And that's it. And now this one is going to be, let's see, we'll do JL. We'll do LJ is parallel to FH. And then I'll do GJ. GJ is parallel to FK. And the last one is, let's see, what did I do? Oh, that's all right. Doesn't matter. You don't have to follow the arrows. I'll do it for this one, though. Let's do LG is parallel to KH. And that's it for those. We know that because, again, 5 and 5, these are midpoint. 6 and 6, J's a midpoint. 7 and 7, L's a midpoint. Connecting the midpoints gets you mid segments. Okay. All right, number 13. In the figure at the right, identify the pairs of parallel segments. So let's see. How much more do we have? Okay, we'll finish up this last slide and then we'll be done because that was quite a bit. So identify the pairs of parallel segments. So it's going to be SU, US is parallel to RQ. We're going to have ST, ST, and ST and PR. And the last one, let's see, we'll do 1, 2, 3, 1, 2, 3. TU and QP. TU and QP. TU is parallel to QP. All right, find the measure. If the measure of QST is 40, so QST is 40 degrees. So if this is 40 degrees, find the measure of QPR. So QPR, take a look. So QST, QPR, these have to be congruent because they are corresponding angles because of our parallel sides. So this one is also 40 degrees. See this corresponding? Goes right here, corresponds. Okay. So we're going to say the measure of angle QPR is 40 degrees. Okay. Identify pairs of parallel segments in each diagram. So AB, let's see. AB, what's parallel is FE. AB and FE are parallel. That's good. BC, here's BC. So GF. And then, whoops, I guess we'll change it to orange. Okay, let's see. EF. So here's EF. So BA. All right, CA. So CA is going to be EG. And then GE is going to be AC. And lastly, FG is going to be CB. And that is it. So in class, we will do this last worksheet on mid-segments. You can start the IXLs, and that's it for lesson 5. Thanks.